Hi, everybody. Thank you so much to Farouk and the panel. That was great. The final presentation we have is from a little company you may have heard of. They're a small startup named AWS, and we have Michael South coming to give us a talk. Thank you, Michael.
Thank you. Good afternoon, everyone. I appreciate you sticking around to the last session of the day. This is actually going to be a speed round, kind of like speed dating. So I'm your first cloud service provider date for today. Well, actually, I don't know. Maybe you had someone earlier. So I appreciate your time. Real quick before I get started, I kind of want to give you a little bit about my background because my personal journey to the cloud is kind of what I'm going to kind of interweave in today. So real quick, I was in the U.S. Navy for 25 years. I was a CIO for Japan. I led the cybersecurity for Asia and the operations officer for all the Navy networks in Europe. In that role, I dealt with your traditional on-prem data centers and networks. I didn't really deal with the cloud other than, say, my personal Dropbox account, right? When I left the Navy, I went to the city of Washington, D.C., where I was the deputy CISO for the city government. And there I had a more of a strategic role for governance, risk, and compliance, and that was my introduction to the cloud in a professional setting. Like a lot of security professionals just starting out, I was absolutely terrified of the cloud. Nope, not going to happen. I'm going to lose my visibility. I'm going to lose control. In a city government, I have, especially in the U.S., that's overly regulated, I got all kinds of compliance frameworks that I got to meet. How am I going to get that done? How am I going to approve it? Completely, totally against it. However, I also pride myself on not being the department of no. And so if I'm going to say no, I got to have data to back it up. I got to have a reason. I got to say why it's not what's best for the mission. And so I tasked my staff and I tasked myself to just take the time, let's learn what this cloud thing really is, because cloud doesn't really tell you what it really is and what it does. And then we'll get that data. I tasked my staff to say, can we do what we're doing now the same way? Terrible, terrible task. Because I handcuffed my staff from day one by saying doing things the same way. And when we're evaluating new technologies, emerging technologies, innovation, we have to be open to doing things differently as long as we get to the same objectives. It didn't take us long to, though, figure out that, yes, we could achieve the same things in virtually the same way. Some of the tools might change, but we could scan and patch our servers. We can implement firewall rules. We can do a lot of the same things the same way. Just have to learn what the new service was or a little bit how it might be a little bit different. But what we also realized, and we weren't quite expecting, was that the cloud also brought to life something that we've always known. Right? I think everybody has things in their life where you know things are not the way they should be. But it's just too complicated, too costly to fix, and so you just do the best you can, you get used to it, right? It is the way things are. And so as we were going through this, the cloud highlighted 4 challenges in an on-prem environment that we've gotten used to over the years. The first is the lack of visibility, right? Now, this initially goes against kind of your gut feeling, right? If I challenge people about lack of visibility in an on-prem environment, the very first reaction is usually, wait, no, that's not true. I physically can touch my servers. I know exactly what I've got. But usually when you start pulling the string on that, you start to realize, no, there's been issues, there's been incidents, there's been things that have happened that highlighted that you don't really have the visibility you need, okay? The other thing that you lack in an on-prem environment is resiliency, right? In my time in the military, my time working for a city government, your most critical applications for, say, citizen services, safety, usually lived on a single server stack in a single data center. We relied on disaster recovery processes to reconstitute maybe somewhere else, but there were never any empty servers waiting for us. We had to hope that the original data center stayed up and running so we could move the hardware and get reconstituted, right? And of course, we never really tested it, and when you did try to do a restore on a backup, it was always kind of questionable what you were going to get. The third area that was a challenge was defense in depth. Right? So we've been talking about defense in depth for decades, but we've never really implemented it because it's extremely complex and costly. Right? I'm going to go over that a little bit more. And the last thing is a low degree of automation. Now, if you're a Windows sysadmin, you can automate a lot of your tasks using PowerShell. But if you're a security professional, where your processes, if you're a security analyst in a SOC, your processes span multiple technology platforms. How do you automate processes that span all these disparate technology platforms? Extremely difficult to do, and especially with a high degree of reliability and consistency. So these challenges we found to actually become benefits of moving to the cloud. So one of the very first major applications or workloads that we moved to the cloud was the DC Healthcare Exchange. So this was our implementation of the Affordable Care Act, or Obamacare, as you may have heard of it. So this was going to AWS, and this is what kind of started me into, well, this is already happening. I've got to figure out how I could be successful, how we could secure this thing and move it to the cloud. So I'm going to cover these 4 things, for these 4 capabilities, kind of at a high level, but I'm going to have some technical diagrams to help out with this. So I've talked about visibility. Right? I can't tell you the number of times in my career where we've had some server popped up out of the blue that we've lost visibility on. Right? Has some old operating system on it, hasn't been patched in a while. Maybe the sysadmin left 6 months ago and has been just sitting running, and we didn't really even notice about it. When I was in DC, we had 2 different hypervisor environments. We had Hyper-V and we had VMware. And you say, okay, we just add those 2 inventories together, right? But the reality was you still have these physical servers out there in data closets. Developers have them sitting under their desk. You have network segmentation. You have endpoint protection software or agents that are either broke or not reporting up, tools that are not getting through the network segmentation. So you have a lot of things that are actually preventing your, getting all your logs and having your accurate inventory. And when you look at CIS controls number 1 and 2, it's all about inventory. Because if you don't know you have it, you can't manage it, you can't secure it, you can't monitor it, and you can't respond to it. So the inventory is absolutely critical to security, and visibility is what enables that, right? And so as we started looking at visibility, the other issue is logging, right? So again, you have all these disparate technology platforms. They're all fantastic, but they're all using different schemas. Ideally, they should be on the same timing source, but oftentimes you find that they're not. Right? You have a log aggregator or a SIM. They just don't all get to where they need to go. And then it's very difficult to sometimes do the correlation across events from a security perspective. So as we look at visibility in AWS, I am not going to go over all these services. We don't have time today, but I'm going to highlight a couple key points. So these are some of the key security services that help with visibility in AWS. The very first one is AWS CloudTrail on the top left. Everything that is done inside of AWS is done via an API, okay? CloudTrail tracks all of the API activity within your environment. Who is interacting with what service, or what service is interacting with what service, when, where. It's all using the same schema, timing source, and because it's on our underlying homogeneous infrastructure, you don't have to worry about network segmentation or endpoint agents or anything interrupting or getting in the way of those logs to the final destination. So this is a huge benefit right off the bat from a logging perspective, right? The next thing is VPC flow logs. A virtual private cloud is a security boundary around your application. And the flow logs is all that traffic coming in and out. Together, they go into Amazon CloudWatch, which is in the center. There's not anything too special about CloudWatch other than the fact that it's the foundation for where all your logs will go. It creates the events and alerts, right? You can encrypt your logs and digitally sign your logs, but this establishes the foundation for you to automate later on. The only other thing that I'm going to highlight here is Amazon Macie, which is in the bottom right there. Amazon Macie is kind of like a data loss prevention or DLP service. Typically, a DLP sits at the perimeter, and it's looking at sensitive data that's leaving your network. And then it either blocks it or it'll allow it and alert somebody. But what about knowing where that sensitive data is to begin with, right? In my experience and a lot of our customers' experience, just look at your share drive, your file server, right? There are so many thousands of files on there that oftentimes organizations don't even know what's there, whether it is social security numbers or for the US, credit card numbers, encryption keys, whether or not they're protected properly or not, right? So Macie scours your S3 storage. S3 is our simple storage service. That's our object store. And it looks for these sensitive data types. It identifies the data, classifies the data, labels it, and it gives you a report on this type of data. So now you know where your sensitive data is at storage before it's ever accessed. So now you can implement those protection measures at the source rather than having to rely on something that hopefully finds it as it's leaving the network, okay? It can also implement rules. So if you have a rule that says all credit card numbers must be encrypted, and it finds an Excel file with credit card numbers in it, it can encrypt that file. The other thing that Macy does is it has some limited user behavior analytics, or UBA. So over time, it learns the natural behavior of the file access and the users. So if you have two people in accounting that accesses that Excel file with credit card numbers Monday through Friday, normal working hours, and then on a weekend at 2 o'clock in the morning, either one of those accounts or a different account starts accessing those files repeatedly, it'll detect that anomaly and alert you. Okay, so now you're starting to get some improved visibility within your environment. You can tag all of your resources and data so you have context to what you're seeing. Right now, if in the traditional way that I kind of grew up with was if you kind of named your servers for what they did. So if you had a Microsoft Exchange server, you would name it EXCH01. So when I got the inventory list, I knew, oh, that's an Exchange server. It does email, right? But now I can add tags to all my resources and data. I can say, not only is this an Exchange server, but this server must meet PCI compliance, right? So I can run reports for every asset that must meet PCI. This asset is part of this organizational unit or this budget code, right? So I can add context to what I'm seeing. The last thing I want to highlight here is AWS Artifact on the bottom right. It's not a real IT service in the sense that it's doing some type of IT function of processing for you, but it is a document repository. We are being audited almost every day of the year for some standard or framework. This is where we put those third-party attestations and those reports so that you can see exactly what we've been audited to, the controls that have been audited, and how well we did on those controls. And this is the list of the security compliance frameworks and standards that we either comply, certify, or align to. There's over 80 internationally that we meet. I'm happy to share, and I think some of you may already know, that we recently achieved Protected B Moderate, or PBMM, for here in Canada. The next is resiliency. This is what kept me up at night from a deputy CISO perspective, thinking about worst case scenario, if we lost a server, lost a data center, what goes down. And so to kind of walk through how you achieve resilience in AWS, you have to understand the cloud infrastructure. This is one of the most important things to look at when you're evaluating cloud service providers, because even though we're all cloud, and we might use the same terms as region, we're not created the same. Our words don't have the same meanings, okay? And you will not be able to achieve resiliency if you move to a cloud service provider who does not have a resilient infrastructure, okay? So the first part of this for us is to understand our infrastructure. So we have 21 regions around the globe and 67 availability zones with 171 edge locations. The dots on the map and the location names on the right are the regions. The numbers in parentheses are the availability zones in each region. I have not shown the edge locations. Edge locations are really our content delivery networks that also we also use for DNS and web application firewalls and so forth. But what's important to understand is what is a region and what is an availability zone, because this is where things start changing. A region is a metropolitan area where we build our data centers. It is comprised of 3 or more availability zones. Okay? An availability zone, or AZ, is a logical fault isolation zone. This limits the impact or the scope of any type of outage. It also allows us to do maintenance on our infrastructure within the region without impacting the entire region. It also is what allows you to architect for high availability within that region. Okay? Within each AZ is 1 or more physical data centers. Our data center, there's typically many more, but we only say there's a minimum of 1. We do not disclose the number or location of our data centers for security purposes. Our data centers are physically separate facilities, okay? This is something you really need to look at. Some providers, you'll have 1 data center might equal 1 region. Or it might be 2 data centers in the same building. If you lose a building, you've still lost everything, okay? So our data centers are physically separate facilities within that region. Our data centers are close enough to also, with the high bandwidth capability, to allow for sub 2 millisecond latency for synchronous data replication within the region. This is what allows you to have high availability for a live or active, hot type of architecture environment within that region, okay? Which a lot of customers have a challenge with their own data centers, even if they're in the same city. All right? Our data centers are on obviously low-risk floodplains and the typical generators and ups and so forth for that. But this architecture is what allows you to start building for high availability within your applications and workloads, but without additional costs. So I'm going to walk through how this might look. So for you, you're on-prem. This is, say, your data center, right? So if you lose a data center, you've lost the application. The firewall at the top is just a representation of your security boundary, whatever that may consist of. If you've lost that, you may have lost the whole application. Load balancers, they're usually physical appliances. Hopefully you have at least 2, but they typically sit at the top, just redirecting between the web servers in a 3-tier web app model. Once you start going below that, if in this particular architecture, if we lose one of the app servers, the load balancers don't know about it. It'll still send traffic down the web servers, right? So now you have customers that are being timed out or having issues, all right? At this point in time, this has a lot of challenges with it. As you start moving to AWS, you're going to select the region that you want to operate in. So for Canada, we have the Montreal region. When you put your data into an AWS region, it stays there. We do not copy, backup, or move your data to any other region for any reason. Now, you can choose to back up your data to another region as part of your disaster recovery model, but we don't do that for you, okay? Within the region, you're going to establish your virtual private cloud. This is the security boundary around your application, okay? By default, in this picture right here so far, there's nothing in the VPC, but by default, it also has no public internet access. You're going to create or select at least 2 availability zones. Now, anybody who's ever done risk calculations and you know n+1, you're going to know the magic number of 3. So I highly suggest you use at least 3 availability zones. You're going to create your subnets, but this is where things start changing. Instead of a physical load balancer appliance that can be very costly, although fantastic appliances, but very costly, you now have this elastic load balancing service, right? Which you're only paying for when it's being used and at a very minuscule amount. You can now have this load balancing service at all 3 tier levels. So at any time, if any server at any side fails, the load balancer shifts the traffic. But you're not just shifting the traffic between servers within a data center. These availability zones represent different physical data centers, okay? So now you're load balancing live across data centers, all right? You're going to add your servers. Now, you could say, well, in this particular model, say on the left, say you didn't have 2 servers in each tier. Say you only had a single server stack, 1 web server, 1 app server. Hopefully, you at least have 2 database servers. And you move to this. You could say, well, that's going to increase my cost, right? That's going to double my cost. I'm going from 1 web server to 2 web servers. But it doesn't, because what changes here is the ability to scale out and in based off of demand. So right now, the one on the left, you are buying, depending on the workload, large, expensive servers for your peak performance requirements. Now I'm going to use an example that's kind of an extreme, but if you are a university and you have a course registration application, most of the year it's not really being used that much, right? Your admin staff is updating the course description, professors, terms, and then 3 times a year, you open up registration season and thousands of students, if you're a big university, start hitting that application. That means you're buying these large, expensive servers to handle that peak load, but most of the year it's not really being used. You can go to something like a bank, where I think they're getting away from this, but does a lot of batch processing at night, right? Or even an office, where everybody's in the office Monday through Friday, normal working hours, but then everybody goes home at night and the servers aren't being used. So you can scale out, which will automatically add more servers as demand increases. okay? And this is, you can configure this based off of either a time and day or based off of a utilization of the servers that are already up and running, all right? So now you can scale out based off that demand. So when course registration season opens up, it'll scale out to the number of servers you need to handle that load. You're only paying for those servers while they're up and running. And then as soon as course registration is done, you scale back to the minimum requirements, all right? So now you have this scaling capability. So those servers, instead of having these very large, powerful servers, you have two very small servers, right, that you're paying just a little bit for every month until you actually need to spin them up. Or in case of a bank, it's usually spin up at night. The other thing this does is it provides a self-healing architecture. So if you've ever been a sysadmin or you know sysadmins, we treat our servers like pets. We give them names, we feed them, we pet them. If a server dies, we cry. It is a bad day. The customers are not getting service. The boss is on the phone yelling when the server is going to get back up. You're spending hours or days trying to reconstitute that server, all right? In this particular scenario, if one of the app servers was to crash, that server failure health will be detected between the load balancers and the scaling group. The load balancers will automatically shift traffic to the other server, which is in another data center. The server that failed will be killed off, and a new server will be spun up within a few minutes and replaced. Once that new server comes on board, checks in healthy, the load balancer reshifts everything. Customer never knows there was an outage. The boss probably never knows an outage, but you got an alert on it. You can go back and take a look. If you're a security professional, you can have that failed server isolated off and do some forensics on it. If you're a developer, you can have it sectioned off, and the developers can go and see what bug might have caused the crash, right? So this is a self-healing architecture. This also allows you to shift from a reactive disaster recovery risk model to a proactive, a reactive, disaster recovery risk model to a proactive resiliency risk model, okay? Not that you're going to get risk down to zero, but you're going to mitigate a significant portion of that risk on the front end, right? So before, it's going to be preventative risk mitigation rather than reactive risk mitigation. So this is how you achieve resiliency on AWS. As we move into defense in depth, again, we've been talking about this for decades, but this is the reality. We put layer upon layer upon layer at the perimeter, and it's all soft and gooey in the middle. This is why phishing emails are so successful, because the attackers know it's very difficult to get in from the perimeter just hitting on it. But if they can get one email through and somebody opens it up on the inside, it's an open trust model. Oftentimes, data centers, you walk into a data center and every server or between your network segments, servers can all talk to each other even if they have no reason to, right? It's open communications. We've got to shift from an open trust model to a zero trust model. And defense in depth is how you achieve it. Now, to do this in on-prem has been very costly, right? You can't really afford a bunch of Cisco ASA firewalls, which is a fantastic product, but you can't afford thousands of them to input in between all of your applications, right? So this is where things start to change. So again, we're back to the VPC. First off, your security boundary is no longer your perimeter network. It is no longer your data center. Every workload will have its own security boundary, right? So now, if there was a compromise in one, it's not going to be able to move over to another application or workload. By default, I said there was no internet connectivity for a VPC. If you need internet connectivity, you can add an internet gateway. By default, every AWS customer gets DDoS protection for free from AWS Shield. You can add our WAF service, our Web Application Firewall service, which is a good WAF, but you can also use partner WAFs that are more feature-rich. So if you're used to using an F5 or a Palo Alto Next Generation Firewall, you can extend that into AWS and start using those partner solutions as well, okay? That's your perimeter. Within the application, you're going to still have your ACLs between your subnets, which is no different. But now you're adding security groups around each tier. A security group is the equivalent of a stateful firewall. right? So I already talked about the openness of a data center, but when you look at an application, even though the application logic will force traffic up and down the stack appropriately, the servers can typically still talk to each other out of order, right? So now you can have the stateless firewall capability and the stateful firewall capability within each tier of the application, okay? To make sure that the traffic communications is going exactly the way it needs to go, all right? And only allowing what is required for that application. In addition, web servers or app servers, as they spin up, all right, in a typical 3-tier web app like this, they have no reason to communicate with each other, right? One web server should not be talking to another web server. If that's happening, one's compromised, they're trying to lat move. They're trying to find something that's open. So within a security group, by default, servers cannot communicate within that security group to each other. Now, you can allow this if you need to. For some reason, you develop that, but it's not. Last thing, you can add your third-party endpoint protection. Amazon Inspector is our scanning tool. You can still use Nessus or Nexpose, and then our logging. So that's kind of a defense in depth within AWS. And then the last piece is encryption, right? So our CTO is saying, dance like nobody's watching, but encrypt like everybody's watching, right? So encryption is key for everything. So you want to encrypt in transit, all the way up to the servers, what we call EC2 or Elastic Cloud Compute. All the storage solutions that we have. You want to manage your keys. So we have KMS, Key Management Service, which is FIPS 140-2, Level 2 validated. You can bring your own keys, or you can have it generate and manage keys for you. No person inside of AWS can actually get to your keys, which is great for security, but just like on-prem, you need to make sure you're managing who has access and managing that. And then again, there's a restricting access. So the last piece, I'm not sure how I'm doing on time. Oh, I guess the time's up. So the last piece, I'm going to do some automation. You are not going to be able to keep up with security without automation. We have Amazon Guard Duty, which is an intelligent threat detection service, brings in intel from Proofpoint and CrowdStrike, as well as our own threat intel. It can find everything in orange, which is your signature-based or stateless findings, everything in red, which is your behavioral or stateful findings. The key here is to automate. So all the detection in the world is great, but you need to be able to automate. Everything creates an event in CloudWatch. AWS Lambda is our serverless function service, so it can take all those events and that information. In this case, say if you have a malicious scan, somebody's trying to attack your server, you have the IP address. This will take that IP address and put it in the WAF and block it for everybody. You can also have it automate and put to other services, communications, your configuration change management database. Don't just automate the response for the threat, automate the update of your configuration change management database, right? Or anything else that you need to. So with that, make sure integrate security with everything you move to the cloud, even as the basic web pages. Thank you so much. All right, thank you.
Thank you.